Thank you. Okay, I see a lot more hands raised in the theater, but you will forgive me if we go to one of our remote sites, because I have been told that UP Mindanao is eager to join us and ask a question. Come in, Mindanao. Okay, why don't I read the question? It's in the prompter. This is a question from a second-year BS Computer Science student from UP Mindanao, Mr. Albert Neil Openda. His question is rather lengthy. I will read it. Your discovery on asymptotic freedom, along with Professor David Politzer of Caltech and Professor Frank Wilczek of MIT, I hope I pronounced that correctly, is a key discovery that explained how quarks, the elementary constituents of the atomic nucleus, are bound together to form protons, neutrons, and their elementary particle cousins. Your work on this research was completed in 1973, but the Royal Swedish Academy of Sciences awarded the Nobel Prize in Physics to you in October 2004. What do you think are the reasons that made it so long for the Nobel Foundation to give you their seal of approval?
QCD, this theory of the strong interactions, when we finished that in the middle 70s, was a theory. The Swedes are very careful with theories, as they should be. They, in the case of theoretical, I mean, when you make an experimental discovery, it usually is quite clear. You've discovered something. It's there. When you present a theory, might be right, it explains a lot of things, but maybe it's wrong. Most theories are wrong. So they are very careful to make sure that the predictions of the theory are really tested. Now in our case, the predictions were quite specific, and there were many, but very hard. It took a long time, very hard work, new accelerators, hundreds of people working for many, many years to truly test the theory. So that's part of the major part of the reason why it takes them often very long to recognize advances in theoretical physics. They don't want to be wrong. They want to make sure that when they recognize an advance in theory, that it is unquestionably true.
Thank you. Our next question is going to come from UP Open University, and we have them with us via video conference. Okay, I think I have the question in the prompter. The question is coming from a tutor in the program Master of Development Communication in the UPOU, Father Gerard Ravasco. He's actually from Sihanoukville, Cambodia. The question: in the field of communication, we are witnessing the convergence of physical, biological, and social science concepts. Do you foresee mainstream physics having more to do with the social sciences if indeed everything is physics?
Well, you know, when I said everything is physics, it's of course true, but not very useful. Starting with a standard model, we can explain the structure of atoms. Starting with one atom, we can explain the structure of water and ice. But from there to just explain the structure of biological cells and then put them together to explain the structure of the human mind are many, many, many steps. And by the time we go along that direction, we can forget about a lot of the physics. I don't think, no, that our continuing advances in the fundamental physics will help us in sociology, but I do think that our fundamental advances that are being made now in our microscopic understanding of biological matter will help us in sociology. And as I said in the end, I look forward sometime in this century to that happening. The social sciences at the moment are very descriptive and non-reductionist. But in the end, they're all about the behavior of humans. And the behavior of humans is governed by our brains. Much of it is built into our genetic code and the way the brain functions. And we have no understanding of that. And it seems to me extremely unlikely that the social sciences will ever get to the same level of understanding and control without having not been, unless they are built on a firm microscopic biological basis.
Thank you. I've been told that UP Los Baños is ready with a question. UP Los Baños, please come in. I think I have the question in the prompter. It's interesting. What is your opinion about intelligent design?
Well, I'm not sure what you mean, what different people mean different things by intelligent design, but if what you mean is that the idea that if you look at life, the different forms of life and the changes that have occurred over the last few billion years, it seems too good to be true. There must be some agent outside of the system that designed this marvelous thing we call life. Well, I think that's totally wrong and contradicted by everything we've learned about evolution, the history of the evolution of life over these billion years, and our increased understanding of, at the microscopic level, of how evolution works. So when one doesn't understand how something works, one is often led to say, well, there is no explanation in the framework you're using, like natural selection, and to invent some outside agent which does it all mysteriously and magically. But that only raises many more questions which have no answer and has no predictive value and no illumination of the problems that we face. And eventually, it seems, and so far it has worked, and increasingly so in biology, that all of the mysterious, hard to understand phenomena that needed to occur for life like us to evolve are quite understandable, and the progress in a detailed understanding of the evolution of life over the last 3 billion years is growing rapidly. So I see no need to invoke anything that I couldn't even define, observe, test, or understand.
Thank you. Now we have a question from UP Cebu. UP Cebu, please come in. I've been fed the question here. This is a question from Dr. Jonifer Sinogaya. Many scientists in the past, including Einstein, were searching for a complete unified theory that would somehow be able to explain everything. But is there really such a complete unified theory? Stephen Hawking, however, suggested that there seems to be 3 possibilities. That there really is a complete unified theory, which someday will be discovered if we are smart enough. 2, that there is no ultimate theory of the universe, just an infinite sequence of theories that describe the universe more and more accurately. And 3, that there is no unified theory of the universe. Events cannot be predicted beyond a certain extent, but occur in random and arbitrary manner. Which of these 3 do you think is possible and why?
Well, I'm a bit of an agnostic. I had a picture on this question, so I don't know the answer. I pictured the geometry of knowledge as a sea of ignorance where we're moving out and creating knowledge that expands. The question you're asking is whether that geometry of the knowledge is compact, is closed like the surface of the earth, or open and goes on together like the surface of a plane. In the past, people used to explore the earth. Originally, they thought the earth was flat and went on forever, and you could explore the earth forever and ever and ever. But then they discovered that the earth had curvature and was round and compact and closed. And eventually, you explored more and more, you ran out of earth to explore, and you explored all the earth. We had a final theory of all of geography. Well, the same is true with knowledge. It could be that the surface of knowledge is flat and goes on and on forever, and we'll always discover more ignorance and more things to learn. Or it could be that it's curved and closed like the surface of the earth, and eventually we'll run out of questions and maybe finish exploring get rid of all the ignorance. Have a theory of everything, a final theory. We don't know. At the moment, it looks flat. When would we begin to suspect that we are nearing a final theory, a theory of everything? Well, when we begin to run out of questions to ask. And we're not running out of questions to ask. There are always new questions, wonderful questions, harder questions. So far we have no indication that the earth of knowledge is round. It might be flat, it might be round. The only way to know is to explore further, which we're doing.
Thank you. Now, UP Baguio is with us. UP Baguio, please come in.
Good morning. We have a question from a BS Physics student, Quantum Yuri Lubrica.